Let's welcome on stage Bianca Kastel, Sven Nobis, and Benedikt Waldvogel, who will tell us how to build a zero trust architecture in public health.
So, thanks for having us. We are going to show you how to build secure software from inside the public administration in Germany, which is quite unusual, probably. So, the things that are that we are trying to explain to you from a software project called GA-Lotse. That's a software platform for public health departments in Germany, how to build secure software. I think the unusual thing is that we are more cooperating for this project from within the government, because the government always has a low level of security in Germany usually, but probably most governments. So we thought about doing it the right way. So that's the reason why we're here at a hackers conference to talk about what we are doing in public administration to build software, to build it in the right way. And to show you what we are doing, we have a small agenda. We're going to show you how the project context was and what our aims were, how we built our software architecture, how we thought about zero trust, then how our secure software development lifecycle was, and how we did implement and test these things. It's probably not all of these things are brand new, but I think it's probably a good example for doing that in some other sectors like healthcare and government to show this as a leading example how you can do it. And we're going to conclude it if shift left approaches and doing secure software coding from the beginning is probably the far better way than doing it the other way around. So, my name is Bianca. I'm the product owner of this project. So, I try to steer this project from within the government. So, I work for the city of Frankfurt, for the Gesundheitsamt, that's the public health department. And I'm the product owner of this project. So, I try to steer it into the right direction, but I'm not alone here. With me is Sven.
Hello, also hello from my side. My name is Sven Nobis. I'm from ELW, and I was part of the security team, and we worked as security consultants for Con, which I will hand over to Benedikt.
Hi, I'm Benedikt. I'm a software developer working for a company in Bonn, which is called Con, and I was, in this project, the lead software architect.
All right, so probably you think about what do public health departments do. Yeah, we usually do things for public health. It's like prevention and healthcare for the population. And the thing is that we have, probably you know us from the pandemic, we were the people with the infectious diseases, the corona cases, and so on and so forth. We usually do things that have to do with health data. So it's usually Article 9 GDPR data, so probably quite sensitive. We do things like school entry examinations, so probably when your child tries to go to school, we have an examination to check for the health, if there's some recommendations that you should go through with the parents. And we also do things like hygiene inspections. We do HIV tests, which are anonymous data because of the discrimination and stigmatization risk. And we also do things like statistics about the health of the population. So it's probably a quite interesting task from a security standpoint to build a really well-built software platform, because we had the chance to build it from the ground up. We sometimes have even more sensitive data, like data for suicide prevention, so you basically have all the challenges for having a high level of security. So, we had the pandemic. You know us from the pandemic. We are the people with the fax machines and data transmissions that don't work, and we don't even know how many COVID cases we have. And so we realized, okay, we have to build our new workplace for the public health people. And so we thought about, okay, what's the workplace, how should the workplace look? We have something like mobile work, we have remote work, and we have also things like security. So we thought about, okay, that's probably a good idea to define a new workplace based on a zero trust paradigm and do it from the ground up, because usually software systems in government are probably quite old and rely on secure networks or something else which is probably not up to date anymore. Before we talk about the technical details, I'm going to show you something as a demo to get an impression about what this entire application looks like, and just to give you an impression that it's not only a secure application, but also a quite pretty application for a government application. So you're going to see here, that's a demo of 1 minute 30, and the things that we have, for example, for Zero Trust, we have passkey only, so no passwords anymore, multi-factor authentication, and then we have a web interface which gives you a nice overview of our microservices built together. We're going to introduce you to them later, and it's probably a quite typical CRUD interface for a web application, but for a government application, probably quite nice looking. The things you see here is things for, some examinations, some appointments. That's for the dentists. And we also have things like, usual calendars for people. We have also the ability to check for the calendars of your entire crew. And we also have some funny loading checks in between, which we're going to explain to you later. What we're also doing is we do statistics, so probably we're going to try to get an impression about how good your health in your local community is. So for example, we can correlate data to specific areas of Frankfurt, probably how good or not how good, well developed the children in a specific area. So that's the application from the front end. So a modern web application, not quite typical for the government, but that's the way it looks right now. So the good news is that we had quite some money. We had some backing from the European Union, which gave the money to the Ministry of Health in Germany, which gave the money to the Ministry of Health in Hesse, and then gave the money to the city of Frankfurt to do this project. So we had 23 million euros. And the interesting thing about this funding was that there's a quite harsh requirement to put 15% of the budget into security and privacy. So we did that because we could. And that was a great opportunity to start with security from the beginning. So we thought about, we have money, then we have some guiding principles. So we thought about, okay, doing it in security by design, security by default. That's always some buzzwords because people always tell you that we're going to tell you that they're doing security by design, but we thought about we're really going to do it. We have a dedicated security team, dedicated testing team, and we also embrace the concept of privacy by design, not just the buzzword, but the real one. And we also did it in open source, so can you look at the code later if you're interested in, or probably try to have your local school child examination at home. Probably a quite rare use case, but you can if you want to. So that's our team structure. We had a quite medium-sized team, more or less. We have 9 business modules teams, which are doing things like data exchange components, which are doing base technologies, which are doing business stuff. But we also had a chance to have a dedicated security team, which was consisting of 5 people. Usually 5 people. And we also have a dedicated test team because also our developers do testing for themselves, but the test team is doing some test infrastructure and doing quite interesting things that we're going to show you later. So that's our team. So we have money, we have a team. Then what's next? We thought about Zero Trust. So Zero Trust is always a little bit different because people have different definitions what is Zero Trust. From our perspective is, okay, Zero Trust is a minimal privileges approach. You have always this approach of never trust, always verify, so nothing is granted, except you can prove that everything is fulfilled. And we have no safe environment anymore, so no perimeters or VPNs or something else. So always check if it's safe. So we also thought about the idea of assume breach, so the concept of we probably will have some breach in the software platform at any time, somewhere soon, probably. So we should think about how can we reduce the blast radius of this entire application and this architecture to keep the data leaks probably and something else quite low. So for a federated system like the German government, that's quite easy because you have some health departments. In the country of Hesse, you have 25, so we're creating 25 tenants for them. These are separated services and separated databases, and we divided them into 25 departments. Then we divided the data inside a department into different database services, different modules, stick them together with an IAM and service mesh, and we also developed, what is probably quite controversial, our own service mesh, because in the German government we have some weird requirements like bridging safe networks in between with specific possibilities and some certificate mixture things like good certificates, manual certificates, and so on and so forth. So we thought about, okay, that's probably quite easy to build a service mesh. It's not, don't do that, but it has worked out for us quite well. And we called it SPATZ for a quite complex acronym that I don't have in mind right now, but it has something to do with proxy and tunneling and so on and so forth. So that's the idea. We have a service mesh of different health departments. They're connected in between. They're also using the service mesh inside the health department. And so we're probably good to go to give the employees or the citizens access to this data. And for the data access, I'm going to hand over to Sven, because he's going to show you how we're doing that.
Thank you, Bianca. So we heard a little bit about how the service mesh works, so how components or models communicate with each other and tenants communicate with each other, and how Zero Trust works there. Now I will talk how we implemented Zero Trust when the citizen or the employee access the website. So how do we ensure that only safe and secure and legitimate user can access applications. For that we have a little diagram here. On the left side there's our browser with a front end which runs on the PC of the employee or the citizen. And the request is first sent to a reverse proxy. We have two reverse proxies in our setup. The first reverse proxy is only for employees, and the second one is for citizens only. So they're separated, so there's no data mix up here. And before a request can access anything behind the reverse proxy, we have the first policy enforcement point here. We have multiple policy enforcement points in our setup, and the first one is in the reverse proxy. It's pretty similar to identity-aware proxy, which you might know about. And when the request is sent to the reverse proxy, he sends this request from the policy enforcement point to a policy decision point, where the decision is made: is this request legitimate? Is it is a token valid? And is the user authorized to access this API or this model? And this is done in the auth model. So we have the auth model at the bottom, and this makes the decision about the things I said before. And only if this is all answered with yes, the request is forwarded to the model. If not, in the case of the employee and this token is expired, then it will be sent to a key cloak where the authentication happens. So this is the only component exposed from the employee portal into the internet without any authorization or authentication. If the authentication and authorization is fine, the request is forwarded to the specific model, and there we have a second policy enforcement and policy decision point. So the model also decides, this is user A, is he allowed to use this API or not? And if not, the request is rejected. Otherwise, the request is forwarded to the application logic. So the application logic is protected in two places, in the reverse proxy first, and then afterwards in the model. And we heard a lot about what we do, how the architecture, we designed the architecture, and the question is, yeah, did we do this? Did we do this in a one-day workshop where we sit together with the 3 people here and say, hey, let's do this? No, this doesn't work. So it's a more complex process, and in the following, we want to answer how did we get to this secure architecture, and not only how did we get to the architecture, but also how did we ensure that the design has no flaws, and the implementation of this architecture is secure and accurate. And the next question we will answer is when it should be done in the development process. Should we do it in the beginning, in the middle, in the end, everywhere? As also an interesting question. And finally, if we do a lot of security, we have also a few challenges there. So let's take a look at the software development process and the software development lifecycle of GEA Lotse. And here we see the life cycle, which is very typical. So we have requirements, design, development, testing, and deployment. In the small bullet points here, there is not typical software development tasks, but only the security task we did. So we had in the beginning, for instance, need to clarify what compliance requirements are required, what regulations we have to follow. And later in the design, we had also a lot of tasks like threat modeling or security by design, security by architecture, which we look further into, and so on. So even at the end, at the deployment, we need to make sure that the deployments in Kubernetes are secure. So there are a lot of security tasks here. And then we also have a lot of challenges here because security needs to be done when the development team needs it. So it doesn't make sense to do the security by design at the end of the project because then it's too late. So they need to be done when the development team is ready to design the component. If we do it too early, they don't have the requirements ready, so we cannot do security by design. So this is a time-critical task often, and the code review cannot not be done months after the implementation is done because the feature needs to be shipped. So this was a few challenges. Another challenges are we need to, software projects have often refinements, so requirements change. So the security needs to be re-evaluated during the project, and security tasks build upon each other. So threat modeling should be done before the security by design, and so on. And now we want to look further into a few interesting details about what we did. We cannot show everything on the slide because we have not enough time, but we picked a few interesting things out of it. And for that, I will hand over to Benedikt.
Thanks, Sven. So we heard all the buzzwords we need, and they sound pretty nice, and they look good on a slide. But I would like to dig a bit deeper into the implementation details, what this actually means if you want to implement something where privacy by design and security by design is done from the very beginning. Before I dive deeper, I would like to do a small recap on the architecture that we talk about here. We have seen this before. So we have a couple of business modules, base module and something like a school entry module, for example, which are specific for business requirements. And they talk to each other. They also talk to the base module. And then there's the front-end server and authentication and identity provider, which is Keycloak. So this looks pretty much like a microservice architecture, and I think it is, but there's a small star next to microservice architecture. I go into this in a second. But anyway, it's a microservice architecture, and this is deployed on a Kubernetes cluster because I think Kubernetes is obviously a good fit here, and we are pretty happy. All the modules talk using REST to each other, and of course communication is encrypted. It's even MTLS, so it means mutual authentication, and this is done using our service mesh that Bianca talked about. So the time schedule for this project was quite tough. We had about 1 year to implement this whole thing, and we had about 9 teams who were developing this project. And you can imagine if you start a project with 9 teams pretty much at the same time, we had a big fear that 9 teams will develop something like 9 solutions for the same problem if they have not so much time. So I think this is a dilemma. In a microservice architecture or a microservice world, you would like that your teams are pretty autonomous. That's the idea of microservices, right? But then you might end up with this 9 solutions for one problem. So you have to decide or have to compromise between team autonomy and centralization. And what we did here is basically 2 things. One is we set up a regular consultation between all the tech leads. So every business module team has at least one tech lead, and they had a meeting every every other week. And they decided which rules they want to enforce in the project. And they also exchanged things they were about to implement, with the idea that if 2 teams were about to implement the same thing, they would realize this in such a meeting and could prevent this double work, so to say. Also, one learning, when you talk about common rules in your teams, it doesn't work if you don't enforce them technically. So what we did is we used something like Arch Unit to enforce, for example, some Java architecture rules in the CI/CD pipeline. The other thing is we ended up with something I call a hybrid microservice architecture. So it's not this classical architecture where every team can decide on the tech stack on its own. So on their own, something like one team implements it in Java and the other one in Rust, and one team uses PostgreSQL and the other one uses MongoDB. That's what you might want to do in a microservice world. But then it's more or less impossible to share a common code. And so what we decided is we want to have this reusability between teams. So we decided to have a unified tech stack, and this somehow violates the classic microservice approach. That's why I say it's like a hybrid microservice architecture. Talking about the tech stack, I did a small survey across our tech leads to get feedback about which technologies that we used in the project were like good and which were not so good. So I will start from the top. And the front-end layer, we use React and TypeScript, and the majority of developers are quite happy with this. But we use Next.js as web application framework, and it works basically quite well for us, but it has some major glitches which made us pretty unhappy. So if you imagine we have a quite big software system with 9 teams, and they all work on the same code base, we even have a Git monorepo. And if you want to upgrade Next.js, and this is a major pain, then this is quite, an expensive progress. And we even had a case where Next.js released a major version which depended on a beta version of React, and this was insane, to be honest. It's not like enterprise stable software stack. The other technology you might see here is on the top right, Joy UI. It's our UI component library, and it looked good in the beginning, but at some time during the project, the maintainers decided to stop maintaining it. So yeah, just bad luck. I guess this happens. On the backend side, we are quite happy. We use Java, Spring Boot, and Hibernate, and it works very well for us. We use Postgres as database. It's a no-brainer, I guess. And one thing I want to highlight here is in the infrastructure layer, there is this rectangle with OpenAPI. So OpenAPI means we do a lot of code generation. So of course, we have a REST API between front end and back end. And what we do is code first. So we implement the REST API as Java code in the backends, and from the Java code, we auto-generate the OpenAPI specification. And from this OpenAPI specification, we then generate the client front-end TypeScript code. So no one has to write any JavaScript code to do some HTTP fetches. And if the interface changes, we get a compile error in TypeScript, and this is pretty nice to evolve the API. However, OpenAPI code generators have some glitches, and this is also quite a pain. And we just hope that this will become better in the near future. All right, so we have a tech stack, but why did we pick those single libraries, you might think? So here we are at the security conference. You might think, why did we use Next.js? It's not the most secure possible implementation, for example. But what I want to emphasize and highlight here is that security is only one piece of the puzzle. And if you only focus on security, you might not focus on other important things. So something like, is the library or framework still maintained? Because if the library or framework is not maintained anymore, this may be an equal risk. And also very important, who's behind a framework. For example, if you look at Spring, you can see, okay, they have some funding and so on, and this is an important point for the decision. Yeah, for example, if you compare Spring Boot, which is really enterprise-stable software for 2 decades or 3 decades even, it's a no-brainer to rely on such a tech stack. But Next.js, it doesn't have such a long history, and the release cycle is sometimes insane, pretty hype-driven sometimes. Yeah, it's not so clear anymore if you want to rely on Next.js, for example. But if the developers decide, they typically decide based on the developer experience they get from a framework or library. Okay, so we clarified the tech stack. We have Spring, Hibernate, a database. It's a pretty straightforward approach to implement something like the school entry module here, right? So we have some school and some child examinations. We have some person names, the names of the children, the date of birth, their parents, where they live, how old they are, what they like, and the examination results. We just store them in one database, right? It's a simple...
No.
Okay.
We don't do that here, because we thought about privacy by design, so we think about what happens if some of these databases are getting leaked. Should we have to have a reference from kid 1 to kid B, or to the parent? So, back to the drawing board.
Okay, so this conversation kind of happened like this at the beginning, right? So we dropped the idea of having one big database, of course. And yeah, now I want to give an example of how we implement it. It's a simplified example, only one example, of course, how we implemented something like privacy by design. So instead of storing everything in one big database, the data is stored in 2 different modules, right? In 2 different Kubernetes pods. So if an attacker would gain access to one of the databases, the attacker would not be directly able to see the other database. That's the background, right? So assume breach, an attacker might breach one database, but maybe not 2 databases. So we store the data in 2 different databases. And on the right-hand side, you can see the data of the school entry module. So for every child which is examined before they go to school, you get an examination result with a child. And it references the child data which lives in the base module. It's a logical reference, right? So you can see here, first line, child ID 3, references Emma Schmidt. And the parents are Maria Schmidt and Robert Schmidt, right? So if an attacker gets access to the right-hand side, they can see all the sensitive health data and examination results, which is bad, but they don't know to which child this belongs, right? And the other way around as well. If you get access to all the person data, you don't know what their health status is. However, there's still one glitch in this model. You might have seen this already. If an attacker gets access to the right-hand side, it's still possible to extract some data in some cases. Here, for example, you can see that those 2 children have the same parents. So it's pretty likely they are siblings. And it's even likely that they are not just siblings, but even twins, because it's a school entry, same age, roughly, right? So they are about the same age, so maybe they're even twins. So you get quite some information just from the ID here in the system. So what we actually do is a bit more complicated. We have one more layer of indirection. So instead of just storing direct references, we have one ID per case. This means if a child is examined, we duplicate the ID of the parent, and for this very case, the ID is generated. So here you can see that the first child has another parent ID than the second child. And if you get access to the school entry table, you are not able to correlate that 2 examinations belong to the same family, for example. So to conclude this implementation example, this is one approach how we try to implement a zero trust. Attacker which gets access to one database cannot correlate it to person data. But this also has a quite heavy impact on implementation. So you cannot just do like a normal database join. Instead, you need to join using remote REST calls, which is pretty expensive, and you cannot do it child by child. So in many cases, you have to do a lot of bulk processing. And also, if you don't do this from day one, it's basically impossible to do, because you can't do a late refactoring and extract the person data from your database into another database. It's not possible. or not easily possible.
Yeah, I will continue. I will keep it in the design phase, and we will deep dive into the threat modeling, and we want to share a few interesting insights about the threat modeling we did. Before I share the insights, I will first give a little bit threat modeling 101. Our approach in Gearlotse was that we based on threat modeling, the threat modeling manifesto. If you did threat modeling before, you might remember this. And our high-level goal was that we want to have a common understanding of the IT security threats in Gearlotse. What means a common understanding? It's not only the security team who needs a common understanding, but all involved persons in the project. So Bianca and the development team, like Benedict, they all need to know the risks and threats in Gearlotse and decide what to do about it. And this is a 3-steps process. So the first steps was to evaluate the risk. What can go wrong in our application? These are our threats. And we did it also in a use case approach. What could a malicious actor do in our application? We come to this later more in detail. And the second part is we try to mitigate the risk. What are we going to do about it? Are we ignore it, or are we try to mitigate it? And we did this in the steps security by design. We've seen a little bit about it, and also in the implementation to implement the functions so that they mitigate the risk we identified in step 1. It's not only necessary to mitigate the risk, but we also need to verify that the mitigations are effective. And this is a question, did we a good enough job? And we try to ensure this by doing code reviews, security testing like pen tests, and security test cases. The last one is very interesting. Benedict will also talk about this later in the talk. We had a no-goal during our workshop, and this was that we didn't talk much about domain-agnostic threats. So threats like SQL injection, XSS. We have a good framework which helps us to avoid those issues. We also had good frameworks which avoid these issues, and also we had already a good process like pen tests, security testing, which should ensure that these domain-agnostic threats are properly maintained. What we focused on during our threat model workshop was domain-specific threats. What specific things, which are not typical for every application, web application, affects Gearlotse. So let's take a look at the threat model in Gearlotse. I have brought you a simplified picture of a threat model diagram for the school entry model. We did first a high-level threat model using strides. This contains also the domain-agnostic threats. We document them, but it was not in a workshop-like. But we did this Excel-like approach to find the typical risk in stride. Using stride. If you did threat modeling before or heard about it, stride is the most common one. But we also did a second part where we did use case-based threat modeling. So you took all use cases of Gearlotse and built abuse cases. The question is, what can a malicious actor do in this use case? And yeah, for that we have also the case study school entry. And what we see here on the right side is a diagram, and you see we see the typical actors, the actors of the school entry model. These are a citizen, an employee, a doctor, and you might think, yeah, they don't have the same level of trust. So we don't trust the citizen, we don't trust the employee, fully trust the employee and the assistant. They can do nasty stuff with the model. But you might question, why is there a threat boundary 4.0? Why is there this threat boundary between the school entry model and the base model? And we heard before about privacy by design. If you don't have the threat boundary before, privacy by design wouldn't work, because if the school entry model is in the same level of trust as the base model, they can access all data between each other, and our privacy by design doesn't work. So threat modeling in a zero trust architecture with privacy by design is much more challenging than a normal threat modeling. But this doesn't apply for the school entry database because the model and the database shares the same data and the same level of trust, so we don't need a threat boundary there. Now let's get over to the use case-based threat model. This looks a little bit different. But first we need to look at the use case diagram. This is a simplified diagram to show you the abuse cases we built later. We have on the right side the employee, the doctor, and on the left side the citizen. And when examination should happen, first the employee in the health department book an appointment, sends out a letter to the citizen with a QR code, and if the citizen gets this letter and thinks, oh, the date is not perfect, my kid has no time there, they want to go play on this day, they can reschedule the appointment. And what the citizen can also do is do a self-analysis, so provide health data about the kid upfront the examination. And at the end, the examination happens and a few other use cases, but they're not relevant for the abuse cases I want to show you. So let's think about what could a bad citizen, employee, or doctor can do when we want to look at these use cases. So we then developed domain-specific threats, abuse cases from these use cases, and I have here a few examples. The first example I want to show you is, we have an attacker. This can be a bad neighbor who is angry because the kid is always too loud, and he finds the invitation letter in the trash. And then he thinks, oh, cool, I can look up what diseases this kid, my neighbor's kid has, takes the QR code and tries to access the data and information provided by his neighbor about his kid. So, and then we thought about how can we mitigate this risk? This is something which might happen in the reality. And the API accepts disease data or health data, but doesn't reveal any data. So you can send data to it, but you can never retrieve any data as a citizen. So the attacker cannot get any data back which was provided earlier. This is a little bit different than a typical CRUD application where you can send data and get the data back. This isn't allowed in this use case. And the second thing we try to address is where we try to address it is we added a second factor. In this case, a birth date. You might think our birth date is not so secure, but it's the only thing which was feasible in this case. So we wanted to have a more secure, but it's not possible. Security is not the most important thing. The application needs to work and needs to be also cost efficient. So we have to deal with birthdays. And this is one of the abuse cases, but we had also more abuse cases, like the attacker has access to the system, the device after they did the analysis, so he has access to the phone and then sees the application is still open, and also in this case we don't reveal any data. Or we have a third case where the attacker finds the trash again, but they try to use the QR code to manipulate data. So say, I sent wrong health data about this kid, and then he not get to school because he's maybe too dumb or something. Yeah. So this was the abuse cases we designed, and now I want to quickly compare this to domain agnostic threats. So this is something which you get often from Stride when you have this big Excel sheet and say, this is a threat which is relevant for me, and this is not relevant for me. And we see here we have, for instance, brute forcing, session stealing, XSS or CSRF or SQL injection attacks. And you can see here on the left side are really real-world scenarios, impact, and you can easily assess the impact and the risk behind it. So I think everyone here in the room can think, this is a scenario which can happen. And also can think, this might mitigate this. The right side is more vague and harder to assess. So how is the risk about XSS? How is the probability that we have an XSS? And as I mentioned earlier, also we have a lot of measures or controls in place to address this risk on the right side. So this was an interesting insight for us, that the left side was a more important, not important, but the more relevant threats to think about, because we couldn't look it up in every dictionary about security, because we need to develop specifically for GEA-Lotse, because there is specific for GEA-Lotse. And the right side is something you can find in a lot of documentation pages, and we have a lot of controls in place to address it. Yeah, this was a little insight about threat modeling. Now I hand back to Benedikt for testing.
Yeah, I would like to talk about the testing that we did in this project, the approach, and also how we applied this approach to automated security testing. So we have a very strong focus on integration testing. This means we do not test our microservices or services in general in isolation, but we always test them together. For example, the school entry module needs the base module, and as you have seen in my implementation example, it's basically impossible to test the real-world scenario of the school entry module if you don't have a real base module along to it. So we always spin those services which require each other up together, and we'll use a lot of automation for this. So we have Gradle as a build tool, and Gradle allows us to automate all of this. So for example, if I want to run the tests for school entry, Gradle automatically builds all the required Docker containers, spins them up, waits until they are healthy, and then executes the test. And when I'm talking about integration testing and real services, I also mean real databases, of course, in Docker, and even Keycloak. So it means we have real sessions. And we can test things which are security relevant. Why do we spin this up locally on our machines? This is because we are way more flexible in testing things. One example is we can change the clock. We can change the time of our modules to test time-specific things. Maybe not for security reasons, but for business testing reasons. So in the backend, we use JUnit to write integration tests, but they are targeting the REST API. So we try to do as much integration testing as possible. And for end-to-end tests, we use Playwright, which drives and spins up a real browser, for example, Chrome, and then clicks in the web page to do things and fetch the text which is shown to run the tests. If you read about or learn about testing, you often see the term test pyramid, which means you have a lot of unit tests at the bottom of your pyramid and only a few integration tests at the top of your pyramid. But we think that this approach is not the ideal approach for many projects. So what we typically do is not a pyramid, but a trophy form. So you can see at the top, it's not a small area, it's the biggest area. So we focus on integration testing. This still means that unit testing and static checks like compilers and linters make a lot of sense, but we want to have those integration tests, because those tests are the tests we rely on when we deploy a new version. So in our project, we have 720 end-to-end test scenarios, and each scenario is like a use case that you click through, right? So very many steps, and over 10,000 backend integration tests. A couple of unit tests and static checks, but what we don't or almost don't do is those component tests in the middle of the pyramid. So a component test, for example, would be you have a Spring component or Spring service, which needs like a database layer and other things. And of course, you don't have this integration test, so you mock all this stuff. And we think this is very bad to do. And why? In a project like this, you often refactor things. One service is split up into two services, or two services are merged into one service. And if you test the service in a unit or component test, it also means if you do a major refactoring, you have to refactor the tests as well. And if you need to refactor the test while refactoring your production code, the test is more or less meaningless. So one important approach we also use in our integration tests is what we call validation files. You might know it under the term snapshot testing. It's essentially like the test runs, and at the end of the test or during the test, it collects some string, often a JSON, and it writes this string to a file. And the file content is compared to file content in your Git repository, for example. And if the file contents match, your test succeeds. If they mismatch, the test fails. And you can see the diff. You can see exactly why, what changed. And this reveals unintended side effects. If you write like simple assert statements, you often don't even know what you might also need to assert. And if you use this validation file approach, you like dump the full response of the server, then you will realize when some line suddenly is missing or some new line is added. And we think this is a pretty good fit for security tests. So here I show an example. It's a backend test which tries to access a REST endpoint, but it does not authenticate. So it does not send some access token or anything. It just runs a post request. And the test asserts that the server responds with HTTP unauthorized. But last line, it also asserts, it checks all the header data that the server responds. And you can see at this bottom part that the validation file, which lives in Git and is checked in the test, contains all those little details that might be security relevant. And if, for example, you upgrade your Spring framework and Spring suddenly changes something in those access control headers, you see it. Your test will fail and you need to accept this change. The developer has to decide, yes, this change is okay or not. Second example, here it's a test which does a regular login using a keycloak, authentication flow, so lots of redirects, and on the bottom you can see we assert the headers of the initial redirect, and the header also contains, for example, the cookie. And we do not have to write assertions for all those cookie attributes, it's just in the validation file. If for some reason some misconfiguration happens and the cookie is not HTTP only anymore, the test would fail. And we do not have to write like tens or hundreds of assertion statements. So I would like to conclude this security testing approach with one more nice example, I think. So we have a couple of business modules, and every single business module is also responsible to check for the role, of course. And we do not want to write authentication tests for every single endpoint in every single module. And often this is not even possible because different teams work on, for example, a library, and this might end up in a new REST endpoint showing up in one of the microservices. So what we have is a generic approach which uses the Spring MVC bean to enumerate all existing endpoints and check which roles are necessary to access the endpoint. So it's a generic way which makes sure that we cannot accidentally add a new REST endpoint which is like publicly available, for example. And all you have to do is like write those 10 lines of code in the microservice module. And with this, I would like to conclude this part. So we saw some deep dive examples for security by design and privacy by design, and how we do some automated testing of security, and the threat modeling. And handing over to Bianca for the conclusion.
Yeah, that was a short wrap-up into some details of GEA Lotse. There are many, many details we have left out because our time is running out, but we can talk to us later about all the details. I think the most important thing about it that the example of GEA Lotse shows, hopefully, is that you can build security from the beginning in almost any environment, even the German government. If you have the right people at the right time, then tell the people that give the money to that it's quite better to introduce a shift left approach and do zero trust from the beginning and do it without any compromise. And I think we have seen that we have made some decisions in our development that we have done from the beginning, and we had to do at the beginning because otherwise errors in these decisions would be quite expensive. So we hope that this is a quite good example and gives you more hope about how you can build government software even from within the government. And with that, we leave you with our contacts, and you probably have some questions left.
Thank you very much. Are there any questions? There's a question.
So, thank you. Bianca, most likely you are the right person for that question. So, why is this still such an, let's say, lonely and outstanding example on how software is developed in that very context? So, can we hope for every software development project in the government context to be stated like this in the future?
I think the good example of the public health departments in Germany, they had some pain in a pandemic. They realized they have to change something. You always get this impression about the government spending more money on security and real security by design when something breaks. So there have to be some breaks. So probably break things, but that was no invitation. But it's usually that you have some pain point to show them that it's better to be prepared, to be prevented for the things that are happening. And within the public health department, it was probably the right time to show the people that it's quite helpful to be better prepared in any situation, be it security, be it data, be it something else, and it's quite helpful to spend money from the beginning, not to have large amounts of money if something breaks. So that was probably the incentive that was specific in this area. And I think the other thing is that we had the opportunity, because I myself am a person that is quite interested in security in my spare time, that has the competence to realize what is necessary to staff such a project. So two things that are quite lucky that got together, but I think it's also, there's some opportunities always being around, like fundings that are thrown out into the public government, and where you can start with that approach from the beginning, probably.
Thank you. Any more questions? I think not. Okay, then thank you again. And yeah, now is the coffee break. Feel free.
Thank you.